Okay, I'm going to talk a little bit about section 3.1 in our textbook, which deals with the constant E and continuous compound interest. And you may have seen in another course where we can calculate compound interest by using this formula where the amount we have after a particular time period is the amount that we start with, or P, multiplied by 1 plus the interest rate divided by n, and n is the number of times that interest is accrued per year, to the power of n times t, where n again is the number of times interest is accrued per year, and then t is the number of years. And as we accrue interest more and more, so for example, we might start by earning interest twice a year, then perhaps 12 times a year monthly, then maybe twice a month, so that would be 24 times a year. And as we see this value of n grow, this expression here, as n goes to infinity, goes to the number e. So e is uh, an irrational, never-ending number like pi, which is roughly equal to 2.718 blah blah blah. All right, so we can, when we talk about continuous growth of interest, we kind of take this formula and it kind of morphs, I guess, into the formula that the amount we'll have after a particular period of time is the amount that we start with multiplied by this number e to the power of r times t, or the PERT formula. So whenever you see a situation where something is growing continuously, typically this formula applies. And again, we're looking at P here as the initial amount. R is the rate of growth. So it's a percentage. And T is the time, typically in years. All right, so we're going to use this formula, PERT, to solve some problems. And again, it stems from this guy right here, where we just let n grow bigger and bigger, and this expression that I've boxed in goes to the value e as n gets large. All right, so the first question is to find the amount that a CD will be worth in 10 years if we invest $10,000 invested at 4.15% compounded continuously. So the amount that we'll have after 10 years, and I can write this kind of as a function of t, so A of t is given as PERT. And so in part A of 10 is given by the amount that we start with, so $10,000 multiplied by the number e raised to an exponent of the decimal equivalent to the rate, so 0.01 or 0.0415, multiplied then by the amount of time. All right, so this thing can be keyed into your graphing calculator, and I'm going to show this just one time because I think sometimes students make mistakes putting this in, and I just want to show it one time. So I'm going to go ahead and make this 10,000 times e to the power of, and there is a key right here above the natural log key, so I'm going to press second natural log to get e to the power of, and now my exponent is 0.0415 multiplied by 10. The nice thing about the newer operating system on these calculators is you don't have to put parentheses around this expression. If you have an older calculator, you may have to include some parentheses around r times t here in the exponent. All right, so the amount that we'll have after 10 years is $15,143.70. So I'm going to include that on as my answer. Actually, I think it rounds to 71 there. All right, and then the Part B says how long will it take for the account to be worth $18,000? So, you know, the setup for this is that I know that I'm going to have 18,000 given I've invested 10,000, and we'll multiply by e to the power of that same rate multiplied by t time. So in this case, I need to solve for, I'm going to make this rate a little clearer here. You know, I need to solve for t, and t is in the exponent. And when we solve for an exponent, you need to use logarithms to solve. And we're actually going to use the definition of a logarithm here to solve this. So the first thing I want to do, though, is to isolate my exponential. So I'm going to isolate e to the power of 0.0415 times t. All right, so the way I'll do that is just to divide both sides by 10,000. So I'll have 18,000 divided by 10,000 equals e to the power of 0.0415 times t. All right, now I want to use, I'm basically going to take the logarithm of both sides of this expression, and so I'm going to take the logarithm base e. So remember, and this is perhaps review, that the log base e has a special name, and that's called the natural log. All right, so I'll take the natural log of, and I can kind of reduce this fraction, 18 over 10, and set that equal to the natural log of the expression e to the power of 0.0415 times t. And when I take the natural log of e to a power here, I get just the power. So this right side simplifies to 0.0415 t. And now I can divide both sides by my decimal value to get natural log 18 over 10 divided by 0.0415, and I've got this thing solved for t. And when I key that in, I see that it takes 14.16 years to earn the $18,000. All right, in the next example, it says an investor bought stock for $20,000. 5 years later, the stock was sold for $30,000. If the interest is compounded continuously, what is the nominal rate of interest that the original $20,000 earned? So in this case, we're solving for R. All right, and I know that after a particular period of time, I had 30,000, I earned 30,000. I started with 20,000, and so I'm just plugging into the PERT formula. And this is going to be times e to the power of r times, and it says it's 5 years later, so r times 5. All right, so this is very similar to Part B in the previous question. I want to isolate this exponential e to the power 5r. So I'm going to divide both sides by 20,000. So I have 30,000 over 20,000 equals e to the 5r. And again, I can knock these bunch of zeros off. So this guy's just 3 halves over here. So now I'll take the natural log of both sides. So I'll have the natural log of 3 halves equals the natural log of e to the power of 5r. And this gives me the natural log of 3 halves equals the exponent 5r. Again, when I take the natural log of e to some power, I get the exponent. And now I can simply divide both sides by 5. So I have natural log 3 over 2 divided by 5. And this is going to give me looks like 0.811. So this is roughly 8.11%. All right, for the next one, it says, how long will it take money to double if it's invested at 4% compounded continuously? All right, so the easiest way to do this is to say, all right, let's start with $1. If it doubles, that gives me $2. And so when I look at my PERT formula, right, I can plug in 2 for the amount that I'll have after the time period, 1 for the starting amount. I have e to the power of, my interest rate is 0.04, and we're going to solve for t. So again, if I take the natural log of both sides, I get the natural log of 2 equals the natural log of e to the 0.04t. And this gives me natural log 2 equals 0.04t. And the time then is just natural log 2 divided by the rate. And that works out to be roughly 17.33 years. So the same problem could have been, how long will it take for your money to triple? And, it would end up being natural log 3 divided by whatever the rate is. Triple is a factor of 3. So, you can see that pattern kind of emerge that could save you a little bit of time when doing these types of questions, solving these types of questions. All right, and the last one, it says we have a mathematical model for the population growth where P equals P naught times e to the RT, where P naught is the population at time 0, R is the rate of growth, T is the time in years, and P is the population at time T. The question is, how long will it take the world population to double if it continues to grow at its continuous compound rate of 1.3% per year? So this is very much like the previous example where I want my population to double. So suppose after time t I have 2 and I started with 1. I'm a big advocate of using easy numbers. So this will be times e to the power of 0.013 times t. So my rate here is 1.3%. So again, natural log 2 equals, and when I take the natural log of this right side, I just get this exponent. And therefore, the natural log of 2 divided by 0.013 gives me how much time? And that looks like 53.3 years.